Tuples are like sealed envelopes. Once you put items inside and close the envelope, you cannot open it and change the items. In Python, you create a tuple with parentheses or even without them. Point equals open parenthesis 3 comma 4 close parenthesis. Point equals 3 comma 4 both produce the same tuple. Because the envelope cannot be altered, tuples are safe to share between parts of a program that should not accidentally modify the data. Common real-world uses are storing a fixed collection such as the latitude and longitude of a place, returning several values from a function, for example return x, y, z actually returns a tuple. Using a tuple as a key in a dictionary because its immutability makes it hashable. If you try to change a tuple, point open bracket 0 close bracket equals 5, Python raises a type error, which protects the data from accidental mutation. Packing is when Python automatically groups several values into a tuple on the left side of an assignment. A equals 1, 2, 3, a becomes 1, 2, 3. Unpacking is the reverse. The tuple is broken apart and each element is put into its own variable. X, y, z equals a, x equals 1, y equals 2, z equals 3. You can ignore values you do not need with the underscore placeholder. X, z equals a, x equals 1, z equals 3, the middle value is discarded. Because a tuple is an ordered sequence, all usual sequence operations work. Indexing, a open bracket 0 close bracket gives the first element. Slicing, a open bracket 1 colon close bracket gives a new tuple 2, 3. Concatenation, a plus open parenthesis 4, 5 close parenthesis results in 1, 2, 3, 4, 5. Repetition, a star 2 yields 1, 2, 3, 1, 2, 3. These operations create new tuples. They never modify the original because it is immutable. A set is a collection that automatically removes duplicates, just like a bag of unique stickers. Union, a union B, all elements that appear in A or B or both. Intersection, a intersect B, only the elements that appear in both A and B. Difference, a backslash B, elements that are in A but not in B. Example with real numbers. A equals open brace 1, 2, 3 close brace. B equals open brace 3, 4, 5 close brace. A dot union open parenthesis B close parenthesis maps to open brace 1, 2, 3, 4, 5 close brace. Mathematically, a union B equals open brace 1, 2, 3, 4, 5 close brace. A dot intersection open parenthesis B close parenthesis maps to open brace 3 close brace. Mathematically, a intersect B equals open brace 3 close brace. A dot difference open parenthesis B close parenthesis maps to open brace 1, 2 close brace. Mathematically, a backslash B equals open brace 1, 2 close brace. These operations follow the usual math rules. They are commutative for union and intersection, and a backslash B is not the same as B backslash A. Sets are handy when you need to remove duplicates or quickly test membership, because the operations run in near constant time. You can also use the operators pipe ampersand dash as shortcuts. A pipe B means unions. A ampersand B means intersection. A minus B means difference. Python sets and dictionary keys must be hashable. A hashable object has two important properties. First, it is immutable. Its value never changes after creation. Second, it provides a stable hash value via the double underscore hash double underscore method that the interpreter can use to place it in a hash table. Common hashable types are numbers, strings, and tuples that contain only hashable elements. Lists, dictionaries, and other mutable containers are not hashable because their contents could change, which would break the internal lookup tables. Example of a failure: S equals a set containing 1, 2, 3, then S dot add a list containing 4 and 5, which raises a type error, unhashable type list. If you need to store a collection inside a set or use it as a dictionary key, convert it to a tuple first. S.add tuple of a list containing 4 and 5, which works because 4, 5 is immutable and hashable. The requirement ensures that the position of an element in the hash table never changes unexpectedly, guaranteeing O of 1 lookup and insertion. In short, only objects whose value is fixed for their whole lifetime can be placed in a set or serve as a dictionary key. A dictionary is like a phone book. You look up a key the name and instantly get a value the phone number. Phone equals Alice 5551234 Bob 5559876. Phone equals Dict Alice equals 5551234 Bob equals 5559876. Key value semantics mean that each key must be unique, but many keys can map to the same value. Lookup is constant time O1 because Python stores keys in a hash table. Internally, the key is hashed. The hash determines a bucket, and the value is retrieved immediately. Example of constant time lookup. Number equals phone Alice almost no matter how many entries. This is fast. If a key is missing, you can use phone get Charlie unknown, which returns a default instead of raising a key error. Dictionaries also support adding, updating, and deleting entries with simple syntax. Phone Charlie equals 5550000 add. Phone Bob equals 5551111 update. Delete phone Alice deletes. Because of the O1 performance, dictionaries are the go-to structure for any situation that needs fast lookups by a known identifier. Each container type ships with a small set of useful built-in methods. Tuples. Count of x returns how many times x appears. Index of x returns the position of the first occurrence of x. Add x inserts x and does nothing if already present. Remove x deletes x and raises an error if missing. Discard x deletes x but ignores if not present. Pop removes and returns an arbitrary element. Clear empties the set. Set algebra methods include union, intersection, difference, symmetric difference, and their operator shortcuts pipe, ampersand, minus, caret. Dictionaries. Get key default performs a safe lookup with a fallback. Keys, values, items return views of the dictionary's contents. Pop key removes a key and returns its value. Pop item removes and returns an arbitrary key value pair. Update other merges another mapping into the dictionary. Set default key default works like get, but also inserts the default when the key is missing. Performance and memory usage differ because each container is built for a different purpose. Tuple small, only the objects it references plus a tiny header. No extra space for resizing. Indexing TI is O1 and extremely fast because the layout is contiguous. Fixed size ordered data that never changes, for example coordinates record fields. Set larger stores a hash table with empty slots to keep O1 membership tests. Extra space grows as the set grows. Membership test X in S is O1, adding or removing is amortized O1. Need uniqueness and fast is this element present checks, for example tags visited nodes. Dict, largest, similar hash table layout plus space for both keys and values. Lookup D of key insertion and deletion are O1 amortized. Mapping from keys to values such as configuration tables, caches, or lookup tables. In practice, a tuple of 3 numbers might take about 48 bytes. A set of the same 3 numbers could be about 200 bytes. And a dict mapping those numbers to strings could be over 300 bytes. However, the speed advantage of sets and dicts for membership and key lookups usually outweighs the extra memory. Choosing the right container is like picking the right tool from a toolbox. Use a tuple when the order of items matters. You have a fixed number of elements that will never change. You want to use the collection as a key in another dictionary. Example latitude-longitude represents a point on a map. Use a set when you care only about what is in the collection, not the orders. Duplicates must be removed automatically. You frequently ask, is this item present? Example, a set of unique user IDs that have already logged in today. Use a dictionary when you need to associate each key with a specific value. Fast lookups by a known identifier are required. The mapping may grow or shrink over time. Example apple 3 banana 5 storing inventory counts. Real-world scenario, suppose you are building a simple game. Step 1 store each player's position as a tuple x, while the coordinates never change unless you move the player. Step 2 keep a set of visited rooms to quickly test whether a room has been explored. Step 3 store a dictionary player score equals Alice 10 Bob 15 to retrieve each player's current score in O1 time. By matching the data shape to the right container, your code becomes clearer faster and uses less memory.